Mr. Biggers here, and today we are going to get into Unit 4, Lesson 5, a sequence of rigid transformations. So in our guided exploration here, we're asking the question, what transformation maps drhk to d prime, r prime, h prime, k prime? So we have d, r, and h and k here, so they're talking about this figure. So how does this figure map to this figure here? So pause the video, see if you can figure that out. Okay, getting back to it, we can see that this figure becomes this figure here by a reflection across the vertical axis, which is the y-axis. So we're going to write reflection across the y-axis here. So it's a reflection across the y-axis. So then how do we map from d prime, r prime, h prime, k prime to double primes? Okay, so how do we go from this one over to this one? So I can see here that the shapes did not change orientation. However, the shape did slide. So it slid from this figure to this figure. So a slide we understand to be a translation. So how far was the translation? Well, the translation went up 1, 2, 3, 4 units, and it went to the right 1, 2, 3, 4. So up 4 and to the right 4. And just for bonus, a reflection across the y-axis, the algebraic description for that, remember it negates your x-coordinate. So it's negative x, y, okay? And then a translation up 4 and right 4 is going to add 4 to your x-coordinate and 4 to your y-coordinate. Make sure you're familiar with those algebraic descriptions. Moving on here, we have a sequence of rigid transformations. A sequence of transformations is when two or more rigid transformations, that means a translation, reflection, or rotation, are applied to a figure one after the other. Remember, the order matters. In most cases, changing the order of the transformations will result in a different final image. For example, a reflection followed by a translation is usually not the same as a translation followed by a reflection. Always perform the transformations in the order they are given. So there's some steps for finding a sequence. First, you want to identify the coordinates and list the vertices of the pre-image and the final image. If an intermediate image is given, list those coordinates as well. So the pre-image will be displayed unchanged, x, y. The intermediate image, so in between this one and the third one, will be x prime, y prime, and then the final image will be x double prime, y double prime, because it applies to transformations. So using the guided exploration, we are going to write the sequence of transformations that maps this figure to this figure. So first, we're going to write the coordinates of the original figure. So the coordinates of point D are negative 2, 2. The coordinates of point R, and I'm looking up here at this figure, the coordinates of point R are negative 1, comma 3. H is negative 4, comma negative 1, and K is negative 4, negative 2. And now we're going to look at the intermediate figure. So what happened from this figure to this figure? So D prime is going to be 2, 2. R prime is going to be 1, negative 3. H prime is going to be 4, negative 1. And K prime is going to be 4, negative 2. Okay? So what pattern happens here? So we got to look at negative 2, 2. Well, we can clearly see that the x-coordinate became a positive, okay? Negative 1, 3. Okay, well, the x-coordinate became positive. And then the y-coordinate became negative. So let's check that out. The y-coordinate didn't become negative. I made a mistake. Point R is at negative 1, negative 3. So that needs to be negative 3. And then if you look here, all of the x-coordinates are just negated. So negative 4 becomes positive 4. Okay, so that's how the sequence maps there. So the algebraic description for that, once again, takes your x, y, and then it changes it, it negates your x coordinate because it's a reflection in the y-axis, okay? So let's go ahead and, so we analyze the first step. So we compare the pre-image to the intermediate image, and we already answered the question. It's been reflected, and we talked about it. It's reflected in the y-axis. Okay, so now we want to complete the sequence. So let's write out the 2 or more transformations in the correct order. So we need to take this intermediate sequence, write it down here, and then see how it changed from this one to the final sequence. Okay, so let me go ahead and copy this down. Pause it real. So there are all those coordinates, and then we want to look at d double prime. So the coordinates of d double prime are up here. The coordinates of that are 6, 6. Pause the video if you want to try to figure this out. And then again, we're going to look at the patterns here. The x coordinate from 2 to 6, it increases by 4. 2 to 6, increase of 4. 1 to 5, it's an increase of 4. -3 to +1 is an increase of 4. So the pattern is working for multiple different points. Therefore, we can make that algebraic description. It's going to take your xy coordinate, and it's going to add 4 to every x value, and it's also going to add 4 to every y value here. Ignore that. So x plus 4 comma y plus 4. Okay, and that's your front page. Pause the video at any point if you need to get any of this. We're going to move on to the next side. We've got example 2 here. So they want us to write the algebraic description for the sequence of transformations. So we're going to look at the first figure. So I'm just going to pick one point to start with, a reference point. So let's start with point A to A prime. So from A to A prime, what happens? Okay. Well, the coordinates of A are -1 comma 1, and the coordinates of A prime right here are 1, 1. So we can see too, just by the picture, that it is a rotation 90 degrees to the clockwise. So remember, when you rotate 90 degrees clockwise, so let's write that down. Rotate 90 degrees clockwise. When you do that rotation, what it's going to do to your x coordinates is going to change your regular coordinate. It's going to flip the order of the coordinates, which you can't really see here because they're just ones, but it flips the order of the coordinates. And then remember that clockwise rotation is going to make your x coordinate negated, okay, with those rotations. Now, if you went counterclockwise, that would make your y coordinate negated. So make sure you remember that rule. And then you got to get from point A prime now, and now we got to see, how did we get from here to here? How did we get from A prime to A double prime? So the coordinates of A double prime are 1 and -1. So the x is +1, the y is -1. So what happened here? So from this shape to this shape, you can see the orientation has changed. It has reflected. So that was a reflection in the x-axis. And remember, when you reflect in the x-axis, what that does to your coordinates, it takes your regular xy coordinate and it's going to keep the same order, but when you're reflecting over the x coordinates, it's going to negate your y value. So that y value of 1 became -1. So that's the rule. So our first thing that happened was a rotation 90 degrees clockwise. The second thing that happened was a reflection of the x-axis. And that's how we were able to put the sequence of transformations together, okay? Now, example 3 says reflect KJGH across the y-axis, then translate 2 units left and 3 units up. Then rotate the image 270 degrees clockwise. So how do we need to do this? I'm just going to pick one point because this can be kind of tricky here. But you could do the rest as an exercise. So let's pick point K as a reference point. So point K has the coordinates of 2, 3, okay? They want us to reflect this across the y-axis. So let's do that first step. reflect across the y-axis. So this is step 1. So remember, a reflection across the y-axis right here is going to negate your x-coordinate. So it's going to become k prime, and it's going to become -2, 3. So that is the reflection across the y-axis. So I'm going to go ahead and plot this point at -2, 3, and that is k prime. Okay, so that's the first thing. Then it says translates 2 units left and 3 units up. So I'm going to do that now. Step 2. So 2 units left and 3 units up. I know that is going to take my, so this is k double prime now, because now we have 2 transformations happening to it. So once again, 2 units left and 3 units up. So 2 left is going to be x minus 2. And 3 up is going to be y plus 3. So we need to apply this to this coordinate. So -2 take away 2 is -4. And then 3 plus 3 is 6. So this is our new coordinate. So we are going to translate it 2 to the left. And then we are going to do 3 units up. 1, 2, 3. So this is k double prime. It has 2 primes with it. Okay? And then, last but not least, it wants us to rotate the image 270 degrees clockwise. So k triple prime now. Okay, so I'm thinking 270 degrees clockwise. So if I'm talking about my rotations and I start here, 270 degrees clockwise is going to move me 3 quadrants. I'm going to be up here. So that's the same thing as a 90-degree rotation counterclockwise. I remember from my notes that when you go counterclockwise, you need to switch the order of x and y. So it becomes yx. And when you go counterclockwise, that's the opposite way than you would normally rotate. So that means your y coordinate needs to be negated. If you want 90 degrees clockwise, the opposite happens. Your x coordinate gets negated, okay? So we need to apply this rule because it's a 270 degrees clockwise rotation or 90 degrees counterclockwise. We need to apply this rule to this coordinate. So we need to flip the order. So I know it's going to be a 6 and a 4, okay? Whatever the y value is here needs to be negated. So the 6 needs to be negated. The x value stays the same. So since it's a -4 here, it needs to remain a -4 here. So then we can plot this point k triple prime. So it's -6, -4. So k triple prime is going to be at -6, -4. And that rotates that figure 270 degrees clockwise, okay? Or 90 degrees counterclockwise. This is a sequence of not 1, not 2, but 3 different transformations. So you can see here how it can get kind of tricky. Okay, now on the next one, I'm not going to work this out, but if you do have me on Canvas, you're going to see the answer key posted to help with the next one. Thanks for watching.